Hello everybody, welcome again to another interesting logical reasoning video from CareerRide. Our topic for today is calendars, a topic that a lot of you have demanded and a topic that a lot of you find difficult. Now, if you see any entrance exam or placement test, you'll see that at least 2 to 3 questions are asked from this chapter, calendars, and a lot of you find it very difficult to solve those questions. But trust me, this is a very easy chapter if you just set your concepts right once and for all. And that is what we are going to do in today's video. So let's learn the chapter and let's see how to solve these questions in a very easy way. Okay, so before we begin to solve the questions from this chapter, it is extremely important to get some concepts right so that you get capable to solve those questions, right? The first thing when we talk about a calendar, all of us know is there are two kind of years that we'll meet. The first is the normal year that contains 365 days. The second type of year that we'll meet is the leap year. And this year contains 366 days, right? So first of all, let us deal with the normal year. And as all of us know, any year, it contains 12 months, it contains 52 weeks, and if the year is a normal year, it contains 365 days. Now, if I try to convert these 365 days into weeks and see how many extra days are left, I'll have to divide it by 7. Okay. So if I divide this 365 by 7 and try to convert it into the weeks, I see that I get 52 weeks, but I also get one extra day, right? One extra day, which I also call as odd day in this chapter. For the purpose of this chapter, this day, which is the extra day which doesn't become a part of the week, is called as the extra day. So these 52 weeks, they form 364 days, while this one extra day is left with us. Okay. So now, why am I sharing this information with you? I'm sharing this information with you because here itself a direct question gets formed in the exams. And the question gets formed is, if a year begins on, say, the 1st January, falls on Wednesday, right? What will be the day on 31st of December of the same year? Okay. So what information do I have here? I know that the week begins on Wednesday. So it means the 7 days get over on Tuesday, and this is where the first week gets over, right? So my second week starts on Wednesday and it again gets over on Tuesday, right? So this becomes my second week. Similarly, I'll keep going on, and this Wednesday, it's starting on Wednesday, ending on Tuesday, my 52nd week comes here, right? And I know that this exhausts my 364 days. But I'm still left with one extra day. One extra day, which I also called as odd day for the purpose of this chapter. Okay. So now what will be this day? The week has gotten over. 52nd week has gotten over on Tuesday. So this extra day will be Wednesday, right? Now it means that for a normal year, the week begins and ends on the same day. And this is a very direct question that you'll find in a lot of exams, right? For a normal year, if the year is a normal year, it is not a leap year, which means the year begins and ends on same day of the week. Mark it star, and wherever you are taking your notes, make sure that you mark it a star there also, because in many exams you are going to find this as a direct question. Okay. Now let's move on to another interesting thing, another interesting concept, and another concept based on which you will find another direct question. Okay. So now that we have seen a normal year, let us talk about a leap year. So all of us know that a leap year is a year that contains 366 days in it, because it has got a February that contains 29 days in it, right? Now let us take a look at this table. In a normal year, we see that there are 365 days, and we saw that we could convert them into 52 weeks, complete weeks, and there was a one extra day left with us, right? What would happen in case of a leap year? If I divide this 366 by 7, I will get complete 52 weeks, but I'll have 2 extra days left, which I'll not be able to put into a week because they are just 2 days only. Okay. Now, in case of a normal year, we took an example in the last slide. Let's go back to that example. If a normal year begins on a Wednesday, the first week will get over on a Tuesday, right? First week this will be. The second week will again begin on Wednesday because Tuesday's first week has gotten over. So second week begins here. So this is my second week, and we saw that the 52 weeks get over like this only, and I am left with one day, and that day again was the Wednesday in case of this example. And we saw that a normal year starts and ends on the same day. Now, taking the same example, if we talk about a leap year, if it was a leap year, then what would happen? It would start on Wednesday. Let's say the 1st of January for this year falls on Wednesday for this leap year. The first week will get over on Tuesday. The first week will get over. The second week will start on Wednesday and get over on Tuesday. Similarly, I'll keep going, and this will happen for 52 weeks, right? So this is my 52 weeks. What is happening now? Now I am left with 2 days. So in this example, this day, the first extra day would be a Wednesday, and the next day in this case becomes Thursday, isn't it? Right? So the last day here becomes Thursday. It means that a leap year, for a leap year, the year ends the 31st December for this leap year would be the next day of January. So if January is on Monday, 31st December in this case would fall on a Tuesday, right? If it is a Tuesday, 1st January is a Tuesday, 31st December would fall on a Wednesday. This is again a very important thing, because many a times a direct question occurs on this basic concept, right? So make sure that you take this also properly and understand it properly. Now, the next important thing for us to know is whether a given year is a leap year or a normal year. And how do we do that? See, whenever some years are given to you, you can divide them into simple years like 1756, 1832, 2001, 2002, and the others would be century years. Century years. These are the years that end with 00. 00 at end, right? So these would be years like 1900, 2000, 2200, right? So these kind of years, they are called as century years. And the way to find whether a given year is a leap year or not is different for these general years and century years. Okay. So for general years, you just divide the last 2 digits of the year by 4, right? Divide them by 4. And if they are completely divisible by 4, the year becomes a leap year. So let's see some examples here. 1756. Here 56 is completely divisible, right? By 4. So it is a leap year. 1832. 8 4s are 32, right? It is a leap year. 1888. Yes, 88 is completely divisible. So it is a leap year. 1929. Is 29 completely divisible by 4? No, 4 7s are 28. We are left with one remainder. So it is not a leap year. 1946. Is it a leap year? 46? No, not completely divisible by 4. So it is not a leap year. What happens to 1996? 96, is it completely divisible by 4? Yes, it is. So it is a leap year. So this is the rule for the general years. Okay. Now what happens when you come across century years? So as we discussed, these are the years that have got double zero at their end. 1600, 1700, 1800. These are century years. And not all of them are leap years. Okay. And how do we find that? For this, we divide these century years. For the century years, the division is by 400. Okay. So 1600, is it completely divisible by 400? Yes, it is. So it is a leap year. 1700, is it divisible by 400? No, not a leap year. 1800, completely divisible by 400? No, it is not. So not a leap year. 1900, completely divisible by 400? No, it is not. So not a leap year. 2000, completely divisible by 400? Yes, it is. So it is a leap year. What happens to 2100? 2100 divided by 400? No, it is not a leap year. So do you see a pattern emerging here? The 1600 here was a leap year, right? After that, there came 3 non-leap years, right? And then again came a leap year. So when we are talking about the century years, between 2 leap years fall 3 non-leap century years, right? So pay attention to this also, because this is again an information that you'll require to solve many questions, and it is going to be very useful to you. Okay, great. So now let me ask you an interesting question here. What do you think? Does a leap year come after every 4 years? Most of us would say yes, because that is something that we have learned since childhood. Now, what if I told you that this is not true? A leap year does not come after every 4 years. Sounds surprising? Let me show it to you with an example. Let's take an example of 1896, 1900 and 1904. From what we learned just now to find how to find a leap year, let us divide 96 by 4. This is a general year, simple type of a year. So we'll divide it by last 2 digits by 4. Completely divisible. So yes, this is a leap year. 1900, this is a century year. So what do we have to do? We have to divide by 400. Completely divisible by 400? No. So it is not a leap year. Now come to 1904. 04, completely divisible by 4? Yes, it is. So it is a leap year. So you can see from here yourself that a leap year does not come after every 4 years. This is a really interesting thing that a lot of us do not know. Okay, but this is a really important thing, because it will make a lot of difference when you solve the questions. You'll require this information to solve the question. Now you would be wondering, why would this happen? Till now we always learned that we have to divide by 4 and we will find the number of leap years, right? But the reason for this to happen is, till now we believe that a year has 365 days and 6 hours, right? This is what we knew till now. And because of these 6 hours get accumulated, and at the end of 4th year we add these 6 hours and form the leap year, right? But in reality these are not 6 hours. These are actually 5 hours, 48 minutes and some seconds. And it was realized that over the years, this difference of approximately 12 minutes in hundreds of years, it really makes a difference. So it was decided that when we make the calculations, we will divide the century years like 1900, 1800, 2000. We'll divide these century years by 400, and that was the reason why century years, or not all century years, are leap years. Like 1900, not a leap year. 1800, not a leap year. But 2000 is a leap year. Being a century year also, we divide it by 400 and it comes out to be a leap year. Okay, so this is again a really important information that you'll require to solve many questions. Make sure that you pay attention to this also. Okay, now the next information that you'll require to solve the questions from this chapter would be how many leap years fall in a period of 100 years. This is a very important information. Mark it 3 stars, I would say. Not just 1 star, mark it 3 stars because this is the information that you'll require to solve almost all the questions of this chapter. Okay. So, the question asked is how many leap years fall in a period of 100 years. Let us take for an example 1 to 100. These 100 years, let's take. Now, by the fact that a leap year falls every 4 years, we should be dividing it by 4. And this should give us 25 leap years and 75 normal years, right? But just pay attention. Consider this last 100th year. What happens here? This 100th year is a century year. So we cannot divide it by 4. We have to divide it by 400. We just saw that, right? From here, it comes out to be that 100 is not divisible completely by 400. So this is a normal year. It means my 100th year is a normal year. It is not a leap year, which means that when I make my calculations here, my normal years increase by 1 and my leap years decrease by 1 because of this 100th year, right? So I have actually 24 leap years and 76 normal years if I consider a period of 100 years. Now come to this table that I have drawn here. So in a period of 100 years, we just calculated that we have 24 leap years and 76 normal years. Now, if I take a period of 200 years, what would happen? I would just double it, right? Because 200 is also a normal year. So 48 leap years and 152 normal years. If I take it for 300 years, what would happen? 72 leap years, 228 normal years. So going by this, what happens in a period of 400 years? From this fact, we should be adding 72 plus 24, that is equal to 96 leap years. And what we should get? The remaining should be the normal years, right? But we see that I have written here in a period of 400 years, there are 97 leap years. How is that possible? Because here again we have to consider that if I consider a period of 400 years, this 400th year is a century year here. So 400 we will have to divide by 400. Is it completely divisible? Yes, it means that this is a leap year. So in a period of 400 years, we will not have 96. No, we will have 97 leap years and the remaining would be normal years. Does that make sense to you? If you find this confusing anywhere, just make sure that you pause the video here and just see all this thing that I have explained on this slide very carefully, because this is going to form the base for this chapter. Don't miss out any information here. Okay, and with this, let's move on to the next thing. Okay, now let's come to another important thing that is going to help us solve the questions from this chapter, and that forms the base actually of this chapter, and it is odd days. So the first thing that I would want to know is what is this odd days actually. So see, for example, if I'm given a period of say 10 days, okay, and I'm required to find out how many weeks can I convert it into and how many loose days I'm left with. So what I'll do, I'll divide this 10 by 7 because a week comprises of 7 days. So I get one complete week and my remainder here is 3. So this remainder that I get is actually my odd days. How? Let's see. So if I divide this 10 by 7, I get 1 week, complete week and 3 loose days. And these loose days that I get, these extra days that I get, that are not able to become a part of any week, complete week, I call them odd days. Okay. Now let's go a step further. Suppose I'm given the month of January. Okay. which contains 31 days, and I'm required to find out how many odd days are there in January. So what I'll do, it means I'm required to find out how many days are there which do not become a part of any week in January. Okay, so what I'll do, I'll divide this 31 by 7 because a week comprises of 7 days. So 7 4s are 28, and I'm left with again what? I'm left with 3. My remainder here is 3. So again these are the number of odd days. How? Let's see. 31 days, they form 4 weeks, 4 complete weeks, plus the remainder was 3. So 3 days, and these days are nothing but the odd days or the loose days or the extra days that are not able to become a part of complete week. Okay. Now let's go a step further. Suppose I'm given a year, and the year given to me is a year that has got 365 days. Now what I'll do? I'll divide this 365 by 7, right? Because I want to find out how many weeks and how many extra days I'm left with. So I get 52 weeks plus 1 day, right? What is this 1 day? This 1 day is nothing but the odd day because it is not able to become a part of a complete week, right? Now, if the year was a leap year, what would I get? I would get 52 weeks plus 2 days, right? And these 2 days are nothing but the odd days, right? So just pay attention that whatever the remainder is left after you divide your given number of days by 7, that is your number of odd days in that period. Okay, and this remainder can only be 0, 1, 2, 3, 4, 5, 6, because the moment it becomes 7, it will become a complete week. So my remainder can only be one of these numbers, 0, 1, 2, 3, 4, 5, 6. Now come to the table that I have gotten for you here. Okay. Now these are the codes of the days, 0, 1, 2, 3, 4, 5, 6, and here. Now if it is a 0, I assume it to be a Sunday. 1 is the code for Monday, 2 Tuesday, 3 Wednesday, 4 Thursday, 5 Friday, 6 Saturday. Okay. So if you get this much right, most of your questions will come out to be right. So make sure that you understand this properly, and if there is any problem, just pause the video here and take a good look at it, because this is the concept that you are going to require to solve the questions ahead. Okay. Okay, so we just saw that if a year comprises of 365 days, that is, if it is a normal year, it will have complete 52 weeks plus 1 extra day, which we'll call as 1 odd day, right? And if it is a leap year with 366 days, in that case it would become 52 weeks plus 2 odd days, right? 2 extra days we will have in this case. This we have already seen. Okay. Now, can we use this information to find out the number of odd days in a century? Yes, of course we can. Let us see with some examples here. Suppose I take a period of 100 years. Okay, come to the table. If I take a period of 100 years, I know that there are 24 leap years and there are 76 normal years here. So each of these 24 years would have 2 odd days, plus these 76 normal years would have just 1 odd day. So I would add just 1 odd day here, right? So what does this give me? This is equal to 48 plus 76, and the total here becomes 124 days. Now, if I want to find out the number of odd days, I have to divide it by what? I have to divide it by 7, because I want to see how many complete weeks are there. So how many complete weeks will be there if I divide 124 by 7? I'll get 17 weeks plus there will be some number of odd days, and these odd days will be 5 days, because this is going to be the remainder. When I divide 124 by 7, I'll get 5 as remainder. So what I have got? I have got 5 odd days. Let us put this information in the table. So if I have got a period of 100 years, I have got 5 odd days here. Okay. Now, if my period given is 200 years, what would happen here? In a period of 200 years, I know there are 48 leap years. So if I have got 48 leap years, it means 96 odd days, because each year has got 2 odd days, plus 152 normal years and only 1 odd day every normal year. So 152. This is what the total here becomes, 248 days, right? Now I want to find out how many odd days are there. So what I'll do, I'll try to convert it into number of whole weeks, and I'll try to see what is the remainder. So I'll divide by 7, right? What does this give me? It gives me what? It gives me 35 weeks plus some odd days. And what are these odd days? These days are nothing but the remainder that I get here, and these are 3 odd days. I've already done this calculation. You can check it if you want. Okay. So there are 3 odd days in a period of 200 years. Okay. So 3 odd days here I've filled up in the table. Now what happens if I have a period of 300 years? I'll go in a similar way, right? So 72 I have got leap years. Now these can be converted into 144 odd days for these leap years plus 228 odd days for the normal year. This is equal to nothing but 372 days. I want to convert them into number of odd days. I want to find out how many number of odd days. So I'll divide by 7 and see what is the remainder. So how many weeks do I get here? I get 53 weeks plus some odd days. And what is that? That is the remainder of 300. When I divide 372 by 7, that is equal to 1 odd day. Let us fill this information also in the table. So in a period of 300 years, there will be only 1 odd day. Okay. Now let us see what happens when I get a period of 400 years. I have a period of 400 years here. What happens? I get 97 multiplied by 2. What is it? It is 194. 194 plus 303. This is nothing but 497. And when I try to divide it by 7, I get how many weeks and days? I get just a whole number, that is 71 weeks, and there is no remainder, 0 days. So in a period of 400 years, there are 0 odd days, right? And now if you try to go further and try to find out for 500 years, 600 years, 700 years and 800 years, you will see that you will get this pattern will repeat. It will become 5, 3, 1, 0 number of odd days again, right? Which means that when it is a leap century year, 400, 800, 1200, then you get 0 number of odd days, right? And now since we know that every century leap year has got 0 odd days, century leap years. What are century leap years? Century leap years are the years which can be divided completely by 400, right? Years like 800, 1600, 1200, 2000. These are century leap years because they can be completely divided by 400. And we just saw that in every century leap year, we have got 0 odd days, which means the year 1600 will have 0 odd days. 2000 will have 0 odd days. 2400 will again have 0 odd days. And if you just keep this much in mind, a lot of questions will become very, very easy for you to solve. Okay, now let us begin to solve some questions from this chapter. And the first type of question that we find here is, what was the day on 6th of April 1896? This is one of the most popular types of questions that you will find in any exams. Okay, and trust me, this is a very easy variety of question that you can solve very easily. All that you have to do is you have to just apply whatever you have learned till now, nothing else. Okay, let's begin to solve the question. So see, 6th April 1896, it means the time has completed till 1895. These are complete years, and 1896 is going on. So let us try to work out this 1895 first. So can I write this 1895 as 1600 plus 200 plus 95? Till here it becomes 1895. And why am I doing this? I'm doing this because I want to apply the concept of odd days that I have learned already. Okay, I know that since 1600 is a leap century year, it will have 0 odd days, right? 200 years, how many odd days are there in 200 years? We have already seen, and otherwise also I have gotten this table for you at the right top corner. See, 5310. This is the number of odd days. 100 years, 5 days. 200 years, 3 days. 300 years, 1 day. 400 years, 0 days. Okay. So from here I know that 200 years have got 3 odd days. Now these 95 years can be written as a combination of leap year and non-leap year. So if I divide this 95 by 4, I'll get the number of leap years here. Okay, so what happens when I divide this 95 by 4? I get 23 leap years I get, and I get 72 normal years. Okay, now I further know that each leap year has got 2 odd days, so there are 46 odd days here, and in this 72 there is just 1 odd day every year, so this is 72 odd days here. Okay, so now this also. Okay, so now let us try to find out how many odd days do we have till now. Okay, so that is 0 plus 3 plus 46 plus 72. So when you add all these three numbers, you get 72 plus 46. This is equal to 118 plus 3, 121. So these are 121 days here. Now I can further sum them up into weeks and I can find the number of odd days. How can I do that? I'll just divide this by 7. So this gives me what? 121 by 7. That is equal to 17 weeks plus 2 days. 2 is my remainder here. When I divide 121 by 7, I get 2 odd days here. So this is the information that is going to be useful me. Let me circle it. Okay. So I have solved this part. Okay. Now let us begin solving the remaining, the year that is going on, 96. So Jan 96, this month has got how many days? 31 days. February 96, pay attention here, 96 is a leap year because it is 96 is divisible by 4. So this has got 29 days here. March has got 31 days and there are 6 days of April with me here. Okay, what is this? This is a total of 31 plus 31 is 62. 62 plus 6 is 68. 68 plus 97. So this is a total of 97 days, but I am only interested in odd days here. So can I find out how many odd days are there? To do that, I'll divide it by 7, right? What do I get? I get 13 weeks plus 6 days, and these are the odd days that I get, right? 6 odd days, and I am only interested in odd days. Okay, so I have 2 odd days from here, 2 odd days plus 6 odd days from here. So plus 6 odd days. This is equal to 8 odd days. But now 8 I can further divide it by 7. Right? I can divide it by 7 and find out, because 7 days would form a week. So this is equal to 1 week plus 1 odd day. How many odd days I'm left with here? 1 odd day. And 1 odd day, our code corresponds to Let's see the table too. So here it is, 1 is corresponding to Monday. So this day should be Monday. You can check out on the internet or in your calendar or wherever you want. 6th of April 1896 was a Monday. And now should I tell you something more interesting about this day? This was the day when the Olympics started in Athens. Okay, this was the day when we started playing Olympics again in Athens. Okay, this was the first time. So quite an interesting question. Easy, nothing difficult here. If you are confused anywhere, just pause the video, take a good look, and I'm sure it will solve very easily for you. Okay, let's go ahead. Okay, so let's see one more question. What was the day on 25th June 1983? So now when I look at 25th June 1983, I know that the number of years till 1982 are totally complete and it is 1983 that is running. So I take 1982 here, okay, because this is already complete, and I can write 1982 as 1600 plus 300 plus 82, right? This is what this is 1982. And why am I writing it like this? I am writing it like this because I know that 1600 is the nearest century leap year that has got 0 odd days. Okay, how many odd days are there in 300 years? We know from our table. See, look at the table on the right hand side. 300 years, it has got 1 odd day. So 1 odd day. Coming back to our calculation, 300 years, 1 odd day. Now 82 years. These 82 years are the years which will comprise of leap years also and non-leap years also, normal years also, that is. So how do I find that? I'll divide this 82 by 4. Okay. When I divide this 82 by 4, what do I get? I get 20 leap years, ly leap years, okay, and the remaining 62 are normal years, non-leap years, okay. So what do I know further from here? 20 leap years, and each leap year has got 2 odd days, I already know. So 20 leap years will have 40 odd days, and 62 normal years, they will have, each normal year has 1 odd day, so they will be 62 only, okay. So now how many odd days do I have from this first part, 1982 part? So it is 1 plus 40 plus 62. From here I can calculate my odd days. This is equal to what? This is equal to 62 plus 63, 103. 103, and this is total of 103 days. And if I try to convert them into weeks and see how many odd days are left, how many extra days are left or loose days are left, I will have 103 divided by 7. I will have to divide it by 7 because a week has 7 days. From here what do I get? From here I get the answer to be 14 weeks plus what? Plus some odd days. And how many odd days these are? These are 5 odd days. I've already done this calculation to make the video faster. You can check it if you want to. Okay. Now I am done with this first part of the calculation and I am interested in this 5 odd days that I've gotten here. Let's mark them 1. Okay. Now I'm coming to 1983, the year that is currently running, and we want to find 25th of June 1983. It means January, February, March, April, May, they have passed and 25 days of June are there. Okay, January has how many? 31 days. February has how many? This is a non-leap year. 83 is not divisible by 4, so it has got 28 days. March again 31, right? Then what do we have? April will have 30, May will have 31 again, right? And then we have got these 25 days of June, right? From this we get a total of how many total days are these? 31 3s are 90, 93 plus 31, 23, 100 plus 28 plus 25. This is equal to 176 days. And now I want to find out my odd days from here. So what do? I'll divide this by 7, right? From there, what do I get? I get the answer to be 25 weeks plus 1 odd day. My answer would be 1 odd day here. Okay, and this is the day that I am interested in. The odd day is the day that I am interested in. Let's mark it 2, right? So from 1 and 2, if we add 1 and 2, how many total odd days do we have? We have a total of 5 plus 1, that is equal to 6 odd days, which is less than 7. So I cannot divide it by 7 any further. Let's see the table to tally it now. 6 odd days, it means as per the code 6 is Saturday. The second table that I've got here. Okay, 6 is Saturday. So this day has to be a Saturday. Let's check it on the internet, or maybe if you want to see it in your calendar, you can do that. This day is a Saturday. Now, there is something more interesting that I want to tell you about this year. This was the date 25th of June 1983. This was the date when India picked up its first cricket World Cup, led by our famous cricketer Kapil Dev, right? So interesting. See, this is pretty easy question, isn't it? Quite easy. All that you have to do is you have to apply the concepts that you have learned and go step by step. And as you practice, these things become easier for you. Don't assume that this question will take 6 minutes or 7 minutes for you. It will not take that much of time. Right now, it is taking time because you are going step by step. Otherwise, you will quickly come to these 5 odd days and this 1 odd day from here, and you will quickly come to this 6 odd days coming to Saturday. But since you are practicing right now, you are learning right now, that is why it is taking time. Otherwise, you can easily solve this type of a question in 45 seconds, right? Don't bother, just practice. Okay, let's see the next question. Question number 3. January 1, 2001 was a Monday. What was the day on December 31, 2002? Now see, if you look at this question and if you think that I'll try to find the number of odd days and I'll go a lengthy way, it will become very tough, and there is no need to do this because this is a very easy question. You can solve it within 20 seconds, not more than that. How? Just see, January 1, 2001 is what is a Monday it is given, and we know that if a year is a normal year, it starts and ends on the same day. So 31st of December 2001 is again going to be a Monday, right? Do I make sense? We have already learned this initially when we were learning the basics of this chapter. Okay, now this tells me that 1st Jan 2002 is going to be a Tuesday. And since 2002 is again a non-leap year, it means 31st of December will fall on the same day, right? So it is again going to be Tuesday. Very simple. You can just mark the answer within 20 seconds if you know this basic, right? So get your basics right. Make sure that you understand the first part of the video very well, and you will be able to solve these type of questions in a very easy and quick manner. Okay, let's move on to the next question. Question number 4. Calendar for 2007 will be same as the calendar for which nearest year in future. Now pay a close attention to the words here, nearest year in future. Okay, because what we have already learned is that the calendar repeats in 400 years, right? So going by that logic, our calendar would repeat in 2407, but this is far future, this is not near future, and you may not find this option at all in the question. Okay, so this question otherwise is very simple. It is just an application of what you have already learned. And what have we learned? we have learned that when the number of odd days becomes 0, the calendar repeats. Okay. So in this case, what we have to do is we have to find out when is it that the number of odd days is becoming 0. Okay. So now we know that 2007, since it is a non-leap year, it is a normal year, it will have 1 odd day. 2008 leap year, it will have 2 odd days here. Similarly, we will find the number of odd days till 2017-18, or you will keep going on till you are able to find the total number of odd days, that give you 0 odd days. Okay, how do we do that? So 1 plus 2 here is, you start adding these days. Okay, because from here you are going to be able to find out the number of extra days. Okay, so what do you find here? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 2017, if you add from 2007 to 2017, you get a total of 14 days, right? And 14 can be completely divided by 7. It means it gives you 0 remainder, right? Which means it gives you 0 odd days, right? It means it gives you 0 odd days. Now if there are 0 odd days in 2017, it means the calendar should repeat in 2018, which means that the calendar of 2007 should look same like 2018. But there is a very small thing that you have to pay attention to again. It should be that 2018 is a non-leap year. So the year that you are arriving at should also be a non-leap year. Why? Understand it here. 2007 is a non-leap year, which means it's 1st January and 31st December fall on the same day. 2018 is also a non-leap year. So it's 1st January and 31st December would fall on the same day. But had this 2018 been a leap year, in that case its 1st January would fall on the same day as 2007, but 31st December would get extended, right, by 1 day. In that case the calendars would not look same February onwards, because in that case the February would be 29 days, right, for a leap year, right? So this is an important thing that you have to pay attention to when you mark your answer. Okay, otherwise a pretty simple question, an easy one, nothing difficult about it. All that you have to do is you have to find the number of odd days, and when you come across 0 odd days, the next year for you is going to be a repeat of the calendar. Okay, pretty simple, nothing difficult here as such, but just apply what you know correctly. Question number 5. Which day can't be the last day of the century? Now, since we are talking about century, we are talking about a very long period. But do not let this long period get you sweaty. I know a lot of students only reading these type of questions, they get sweaty. But there is no need to do that, because this is a very easy question and you can solve it within seconds if you just apply your basics correctly. Okay, and that is the reason I always insist on getting your basics right. Okay, let's see this question. When we say century, it means we are talking about 100 years, 200 years, 300 years or 400 years. Why only till 400? Because we know that after this the calendar repeats, right? So that is why we are considering only these 4 century years. Okay, now see, how many odd days are there in 100 years? We have already seen this, okay, in our basics. There are 5 odd days here. 200 years, 3 odd days. 300 years, 1 odd day. 400 years, 0 odd days. And we also know that these number of odd days, they correspond to some days through our code table. Okay, So 5, we have seen that it corresponds to what? It corresponds to a Friday. If you look at the table on the left hand side, it corresponds to a Friday. 3 corresponds to what? 3 corresponds to Wednesday. So the last day of 200 years would be a Wednesday. What happens to 300 years? The last day, we have only one odd day, so it would be a Monday. Right? And what happens to 400 years? There are no odd days, there are 0 odd days here, and it corresponds to a Sunday. Right? So these are the last days of the century that we see, and after this the calendar would keep repeating like this. So this is the only cycle you are going to get. Okay, and which days do not make it to this table? We have Sunday, Monday, Tuesday doesn't make it to this table. Then Wednesday is there, Thursday doesn't make it to this table. Then Friday is there, Saturday doesn't make it to this table. Right? Saturday doesn't make it to this list. So Tuesday, Thursday and Saturday are the days that cannot be the last days of a century. Okay, extremely easy question, isn't it? Just you have to know how to apply your basics correctly, and you will even solve the difficult looking questions very easily. Let's go on to the next one. Question number 6. How many days are there in Y weeks, Y days? Now see, this question may look difficult to read, but this is an extremely easy question that you can solve within 10 seconds. How? See here. We know that 1 week is equal to 7 days, right? So Y weeks, what would that be? That will be equal to 7 Y days, right? What is given to you other than this? You have Y days also with you, right? So plus Y days. What is this? This is nothing but 8 Y days, right? So see how easy the answer is here. How easy it is to arrive at the answer here. All that you have to do is find the number of days in a week and add them. The question is only difficult to read. Mind it very carefully. So read the question very carefully and tell your mind that this is an extremely easy question, and your mind will immediately start looking for the solution. That's the most simple trick that I always give to the students. Make sure that you also apply it. Okay, let's move on to the next question. Question number 7. 15th of January 1977 was a Saturday. What was the day of the week on 15th of January 1976? Trust me, an extremely easy question which you can solve in 30 to 40 seconds. Okay, you just have to make a logical application of what you already know. And what is it? You are given that 15th of January 1977 was a Saturday. This was a Saturday. It is given to you. Now from the code table of the days, see this table on the right hand side. We already know this table. Okay, we have seen it earlier also. So our code for Saturday is what? It is 6. So write 6 here. Now what is given to you about 1976? 15th of January 1976. Now 76, this was a leap year, right? 76 is completely divisible by 4. So this was a leap year. It means it has 2 odd days, right? 2 odd days. Simply subtract this 6 minus 2. Okay, what do you get? You get 4. So 4 is corresponding to which day? 4 corresponds to Thursday. So it means that 15th of January 1976 was a Thursday. Just see, this is an application of what you have already learned, nothing else. Okay, if you want, you can go to your calendars and check. 15th of January 1976 was a Thursday. If you find this question confusing anywhere, I would advise that you pause the video here, take a careful look at whatever there is on the screen, and then go ahead. Question number 8. Calendar for the month of April looks same as that for the month of. Now see, this is again a very easy question, And the reason I'm calling it easy is because it just needs you to apply the concept of 0 odd days, right? The 0 odd days concept that we were till now applying to years, that you have to apply to months now. Okay, and the moment you meet 0 odd days, the calendar begins to repeat. That is what we already know. Now let us see, the month of April is given. April has got 30 days. Let's go forward. May has got 31 days, June has got 30 days again. Okay, so when you sum all these three up, what is the answer that you get? You get 91 days. And when you divide these 91 days by 7, because there are 7 days in a week, what is the answer you get? You get 13 weeks plus 0 odd days. Now that there are 0 odd days, the calendar is ready to repeat, which means the calendar for the month of April will be same as that for the month of July, because at the end of June there are no odd days. Between April and after June there are no odd days. So the calendar for the month of April will be same as July, right? So this is again a very simple thing, and you can solve these type of questions very easily going by the logic of 0 odd days. So guys, with this we come to the end of this chapter, and I sincerely hope that whatever we have learned today in this video is going to help you solve the questions from this chapter of calendars in a very easy manner. If you found this video useful, make sure that you give it a thumbs up and share it with your friends also. And if you want to stay updated with more logical reasoning and quantitative aptitude videos that you require to crack your placement tests and entrance exams, make sure that you subscribe to the channel. I'll see you very soon with a new video. Till then, bye bye and take care.